In this video, you are going to see about the deformation of the conical and the taper rod under two conditions. One is deformation due to the external force and deformation due to the self weight. So in the previous video, we have seen the deformation of the uniaxial uniform section bar due to the external force acting on the body and due to the self weight acting on the body. So in the deformation of the conical section due to the self weight, consider the MNH, a conical bar of length L and the diameter of the conical bar D in mm and density of the material of the bar in kg per meter cube and Young's modulus of the material in Pascal, and consider the strip thickness SUTV, that is dy in mm, and strip diameter uv as ds. So this dy is the small element on the conical bar at a distance of y from the sharp end h. So the weight of the conical part UHV is equal to 9.81 into the mass of UHV. So 9.81 is the conversion for Newton. So 9.81, the mass can be written as density into volume. So 9.81 into rho pi by 4 ds square into y by 3. So the final equation will be 9.81 into rho into pi by 12 into ds square y. So considering the similar triangles MNH and UHV, so Mn by UV is equal to L by Y. So we can write UV as Mn into Y by L. So Mn is the diameter of the conical part. So we can write ds is equal to d into Y by L. So the weight of the conical part UVH is equal to 9.81 into rho into pi by 12 ds square y. So this ds, we know that ds equal to d into y by L. On substituting d into y by L, we will be getting the equation as 9.81 rho into pi by 12 d by L the whole square into y cube. Considering the stress at the section UV, we know that stress is equal to load by area. Force at UV to the cross-sectional area of the UV. So load at UV we know 9.81 rho into pi by 12 d by L the whole square y cube divided by cross-sectional area at UV. So UV diameter is ds. So we can write pi by 4 d into y by L the whole square. So we will be getting at 9.81 rho y by 3. So the extension of the strip dy can be written as stress in the strip and divided by modulus of elasticity. So stress in the strip, we know 9.81 rho y divided by 3e. So the total extension of the conical bar can be found out by integrating the extension of the strip between the limits 0 to L. So 9.81 rho y by 3e is integrated within the limit, lower limit 0 to L. So we will be getting the final equation as del L is equal to 9.81 rho L squared by 6e. So this equation is applied to the deformation of the conical bar due to the self weight. So coming to the deformation of the taper section due to the external force. So this taper section has two diameters, diameter varying from D1 to D2 with the length of L. So the Young's modulus of the material is E in Newton per meter square or Pascal, and load applied, either it may be a tensile load or it may be a compressive load in Newton, and the stress induced in the body is taken as Newton per mm square, and strain will be developed. The strain has no unit, and if the force applied is compressive, so deformation will be negative. If the force applied is tensile, the deformation will be positive. So this deformation under the taper section, consider a small strip or a small element of dx at a distance of x from the bigger end. So the diameter at the position of x, we can write d2 minus d1 into x by L. So this d2 minus d1 into x by L can be taken as k. So we can write the diameter of the position x is equal to d2 minus kx. So the cross-sectional area of the elementary strip can be written as pi by 4 into d2 minus kx the whole square. Now the stress at the section x can be written as stress is load by area. So we can write stress at the part of x is equal to p by pi by 4 d2 minus kx the whole square. So on rewriting, sigma x will be 4p divided by pi into d2 minus kx the whole square. Then strain at the part of x is equal to stress divided by Young's modulus. So we know what is the value for stress, that is 4p divided by pi into d2 minus kx the whole square by E. So on rewriting will be, the equation will become 4p divided by pi into E into d2 minus kx the whole square. So the elongation of the element dx is epsilon x dx. So we know what is epsilon x, that is 4p divided by pi into E of d2 minus kx the whole square into dx. So the total elongation can be founded by integrating this elongation between the limits 0 to L. So del L equal to 4p divided by pi into E, integrating between the limits 0 to L dx by d2 minus kx the whole square. So on integrating, we'll be getting the equation del L equal to 4p by pi E into d2 minus kx inverse divided by k between the limits 0 to L. On substituting, del L will become 4p divided by pi ek into 1 by d2 minus kx between the limit 0 to L. The final equation will be 4p by pi ek into 1 by d2 minus kl minus 1 by d2. So del L will be equal to 4p by pi ek into 1 by d2 minus of d2 minus d1 minus 1 by d2. On rearranging, we will be getting del L equal to 4p by pi ek into d2 minus d1 by d1 d2. So the total elongation of the bar is found out by substituting the value of k, d2 minus d1 is equal to by L equal to k. On rearranging, we will be getting the final equation, the total elongation of the taper section due to the elongation due to the external force equal to 4pl divided by pi e d1 d2. So coming to the deformation of the taper section due to the self weight. So this taper section SUVT is hanging freely under its own weight. So this sketch is the point formed by extending the SU and TV. So this L is the length of the taper rod and L dash is the length of the taper portion after projecting. So D1 and D2 will be the diameter of the sections and rho will be the density of the bar material and E will be the Young's modulus in Newton per mm square or Pascal. So this extension in the length of the rod due to its self weight equal to the extension in UHV due to self weight minus extension in the SUVT part due to the weight of UHV. So first extension in the conical part SHT due to self weight, we know this equation del L is equal to 9.81 rho L dash square by 6E. So this extension in the conical part SHT due to self weight 9.81 rho L dash square by 6E, and the extension in the conical part UHV due to the self weight will be replacing L dash by L dash minus L, will be getting 9.81 rho into L dash minus L the whole square by 6E. So this weight of the conical part UHV is taken as P. We know that weight is equal to 9.81 into mass, and mass will be equal to density into volume. So on substituting the values, rho into, rho is the density and volume will be pi by 3 area into h. So pi by 3 here area can be calculated using the diameter. So d2 squared is the diameter. So on rearranging, weight will become 9.81 rho into pi by 12 d2 square into L dash minus L. So this extension of the taper part SUVT due to the weight of the conical part UHV. So del L equal to 4PL divided by pi E into D1 into D2. We know this equation from the previous section. And also we know the weight is equal to 9.81 rho pi by 12 into D2 square of L dash minus L. On substituting, the final equation del L will become 9.81 rho into L dash minus L into L by 3E into D2 by D1. So the total extension in the uniform taper circular section due to the self weight can be obtained by change in length of the SHT part due to its self weight minus change in length in UHV part due to self weight minus weight of the UHV part. So we know the relation 9.81 rho L dash square by 6E for the self weight due to SHT and 9.81 rho into L dash minus L the whole square by 6E for UHV part due to self weight and 9.81 rho into L dash minus L into L by 6E into D2 by D1 for the weight of the UHV part. On substituting all this, now taking the similar triangles, we can tell cot theta is equal to D2 by 2 and cot theta is equal to D1 by 2 L dash. So now equating the cot theta, we will be getting D2 by L dash minus L equal to D1 by L dash. On cross multiplying, D2 by L dash minus L equal to D1 by L dash, you will be getting the final equation L dash equal to D1L by D1 minus D2. So we know L dash equal to D1L by D1 minus D2. Now L dash minus L can be found out by subtracting L from the previous equation and L dash minus L will be L into D2 divided by D1 minus D2. Now substituting L dash, the value of L dash and value of L dash minus L in the deformation equation, we will be getting 9.81 rho by 6E into D1L divided by D1 minus D2 the whole square minus 9.81 rho by 6E into D2L divided by D1 minus D2 the whole square minus 9.81 rho by 3E into D2 by D1 into L into D2L by D1 minus D2. So on rearranging, we'll be getting the equation as 9.81 rho L square by 6E into D1 cube plus 2 D2 cube minus 3 D1 D2 square divided by D1 into D1 minus D2 the whole square. So the extension in the uniformly tapered circular section due to the self weight, the final equation is del L equal to 9.81 rho L square by 6E into D1 cube plus 2 D2 cube minus 3 D1 D2 square by D1 into D1 minus D2 the whole square. So in this video, we have seen the equation of deformation of the conical rod due to the self weight and deformation of the taper section due to the external force and deformation of the taper section due to the self weight. So these are the equations to remember. Thank you.